for CSE, IT, CSBS and AADS sub department, and the subject code is CS3351. Unit 1 Combinational Logic. This is the fourth part video. Analysis and design of combinational circuit. How will you analyze and design a particular combinational circuit? Before that, what is meant by combinational circuit? A combinational circuit is used to perform the operation by using the AND gate, OR gate and NOT gate. So what are the example of combinational circuit? Half adder, full adder, off subtractor, multiplexer, demultiplexer, so encoder and decoder. These are all the example of combinational circuit. This circuit will be designed by using this procedure. This is the flow chart of how will you design the combinational circuit. The first step in the analysis and design of combinational circuit is circuit specification. You need to specify that circuit. For example, if you are going to do addition operation means you need to use OR gate here. In some, if you want to construct some other digital circuit with inversion or multiplication operation, you need to construct and NOT gate. First of all, decide the circuit according to this function. Afterwards, you need to draw the truth table for designed circuit. Then you need to draw the K-map and algebraic manipulation and computer based tool. Afterward, the final step in the combinational circuit is to do the logical diagram. This is the fourth step to construct an combinational circuit. This is a procedure to design a combinational circuit. First step is to find out the number of input and output required for the combinational circuit and assign a symbol to each. For example, if you need two input means you will mention the name as A, B or XY as your wish. Afterwards, you need to find out how many output you are going to get. It may be either 1 or 2. After doing the first step, next step is to draw the truth table for input and output with the given specification and function. With the help of the third step is with the help of the truth table, you need to find out the boolean function for each output function of input variable. And the final step is to draw the logical circuit or logical diagram for the given input and given output. What is the drawback of combinational circuit? As I mentioned before in my previous video, the first drawback is it doesn't have any memory to store the value. So it is only going to provide an output only for current input and not on past and the future input. So it is one of the drawback considered for the combinational circuit. For this property, you can use sequential circuit. Your second unit is based on the sequential circuit. There you will read about what is meant by sequential circuit what are all the example of sequential circuit. The drawback and difference between combinational circuit and sequential circuit is memory. So in combinational we can't able to store any data or information, but in sequential circuit we can able to store any data or information. You can able to construct the combinational circuit with the help of logical gates like AND gate, OR gate, NOT gate. At the end subtractor, Usually, the binary adder is used to do the addition operation with binary adder is used to do the addition operation with one or two input variable to provide two output variable. We can able to give two output variable with the help of three input variable as A, B, C. Uh, Binary adder is usually classified into two. One is off adder, another one is full adder. In subtractor, there will be a two subtractor. One is off subtractor and full subtractor. In binary adder, the off adder has two input. In full adder, it has three input. But both is going to provide the two output. First one is off adder. It has this two input to provide an output of sum and carry. So it has usually two input and provide an two output. The two output will be named as sum and carry. For example, if you are adding 1 plus 1, okay, this this is A input and this one is the B input. You will get an output as 10. In this values, this is the sum and this will be the carry. This is the block diagram of off adder. We will construct the block diagram with two input that is mentioned with A and B, and you will get an output as sum and carry. This is the truth table of off adder. In off adder we will have two input. So as the same procedure to fill the input values. For A fill 0011, for B fill 0101. In output you will get two values, one is sum, another one is carry. You will add 0 plus 0 means the sum will be 0, so there is no carry, that's why you will mention here as 0. 0 plus 1 is sum will be 1 and carry will be 0. 1 plus 0 also sum, the sum will be 1 and carry will be 0. Here I will add 1 0. 1 plus 0 is only 1. So this will be the sum value and there will be no carry value. If there is no carry value means you need to mention as 0. 1 plus 1 is 10. Okay. 10 means the sum will be 0 here and the carry will be 1. That's what I mentioned in this word. The carry output is 0 in the case where both the inputs are not 1. Okay. So here the carry will be 0, right? But here the A and B values are both the values will not be 1. Either A will be 1 or B will be 1. How to find the logical expression for off adder? For sum, use A and B as input and 0 1 0 1 and mention that values. With the help of the truth table, fill the K-map. When A and B is equal to 0 means the sum value will be 0. When A is equal to 1 and B is equal to 1 means, 0 means the sum value will be 1. Like that, when A is equal to 0 and B is equal to 1 means the sum value will be 1, and A is equal to 1 and B is equal to 1, both the value is 1, you will get a sum value as 0. Here see, input A is 1 and B is also 1, and you will get the sum value as 0. And you need to group this. First group this value, that is here. Here I will mention that sum and carry value with the x dash xy variable. So if you have A and B input means the sum will be equal to A dash according to your K map grouping, A dash B plus A B dash. For carry, when both the values will be 0 means 0, and when either one of the value will be 0 means the carry value is 0. So A is 0 and B is 0 means you will get the value as 0. A is 1 and B is 0 means again 0. B value is here 1 and A value is 0, you will get carry as 0. Finally 1, A is 1 and B is 1 means you will get a value as 1. See this truth table. A value is 1, B value is 1, so the carry will be 1. For some A and B, and it will be mentioned as AB. The carry will be mentioned with AB. How to construct a off adder circuit? So already I told you it contains two input and two output. The two input state and carry and sum are the output state of the off adder. To design the off adder, we will use two gate. One is AND gate and another one is XOR gate. Two input AND gate and another one is two input XOR gate. So this is a two input XOR gate to construct a off adder. It has two input A and B, and some output will be A exclusive B. In my fundamental of logic gates video, I have explained about the XOR gate function. If we have same variable, same input as input values, we will get the output as 0. If we have different input, we will get output as 1. So here see, A is equal to 1 and B is equal to 0. So this is the different output. So you will get in different input. So you will get an output as 1. And the last value is A equal to 1 and B equal to 1. You will get this is the same value. So similar value means you will get the low output value, that is 0. Next gate is used to design the off adder is two input AND gate. So AND gate is used to perform the multiplication operation. Here in off adder we are going to use to get the sum and carry as output. So this is the truth table for AND gate. A and B is considered to be an input and output. Here you will mention any variable like C or Y. 0 into 0 is 0, 0 into 1 is 0, 0, 1 into 0 is 0, 1 into 1 is 1. This is the logical circuit of off adder by constructing using the XOR gate and AND gate. So first construct the XOR gate and mention that two input variable is A and B. With this input, connect the AND gate with XOR gate. So A input is connected with the AND gate and B input is connected with another end of the AND gate. And AND gate is going to provide the value for carry. XOR gate is going to provide the value for sum. So sum will be known as XOR gate. So this will be equal to A dash A XOR B. What is the formula for A XOR B? A dash B plus A B dash. For carry A B. Okay. This is the logic equation for sum and carry, and this is the logical circuit of adder. Next topic is full adder. In off adder we will have two input and two output, but in full adder we will have three input is combined to form an two output, that is sum and carry. Sum and carry. With the help of the full adder, we can able to add up to three variable. Up to three variable. The variable will be mentioned with A, B, C or X, Y, Z. This is the block diagram of full adder. So A, B, C we will have three input variable to get an output as sum and carry. This is the truth table of full adder. A, B, C is three input variable. If you have three variable means you will fill the truth table with first input variable with 4 zeros 4 1 and second variable with 2 0 2 1 0 2 1 and the final variable with 0 1 0 1. So this is sum and carry of this three input. First A is given as 0, B is given as 0 and C is given as 0 means if you add 0 with 0 you will get a value as sum as 0 and there will be no carry means you need to mention that the value as 0. A is equal to 0, B is equal to 0, C is equal to 1. 0 plus 0 is 0. First of all you need to add A plus B. Afterwards you need to add the C with A plus B value. For example, I will take this value. Okay, 1 plus 1. 1 plus 1 is 10. Afterwards, you need to add the C value as 0. So, this C value as 0. So, 0 plus 0 is 0. 1. This will be sum. This is sum. Okay. And this will be carry. Come to the last value. A is equal to 1, B is equal to 1 and C is equal to 1. 1. First add A plus B value. 1 plus 1 is 10. Afterwards add C value. So 10 plus 1 is 11. So 1 plus 0 is 1 and write the remaining one as it is. Here the sum will be 1 and carry will be 1. Sum will be 1 and carry will be 1. This This is the K-map of full adder. This K-map is mentioned with x, y, z. So x is the, if you have three variable means you need to find out, draw the K-map for 8 values, 2 to the power of 3. And write the equation in the sum of product form for full adder. If you have three values is 0, means the sum will be 0. If you have x is equal to 0 and y is equal to 0 and z is equal to 1 means 1. So like that you need to fill the 1 in that respective position. Afterwards do the grouping. So this will be, write down the group. So we can't able to do the group in diagonal position. That's why there will be 4 group. So first one is mentioned with this. This is first one. X dash here in this one is meant in the place of when x equal x dash, y dash and z. Okay. So this is this one, x dash, y and z dash. This will be the x value and this two will be y z value. Like that you need to fill the K map for carry. Afterwards do the mapping. When you will get the carry value as 1, you will get 4 1 1. When a equal to 0, b equal to 1 and c equal to 1, you will get the value as 1. Afterwards when a equal to 1 and c equal to 1, you will get the value as 1. Again in the last two values you will get the carry as 1 value. So x equal to when 0 and y equal to 1 and z equal to 1, you will get a 1 value. Like that afterwards do this two group, this group 1 and afterward this one is one grouping and group in vertical position. Write out the equation as per your K map. We will get a value as xy plus xz plus yz. This is the logical diagram of full ladder. Full ladder logical circuit can be constructed using the and the XOR gate with an OR gate. In off adder we will use and the XOR gate. Here we will use one more gate that is called as OR gate. This both will be the of full adder logical circuit. Either you can draw the ABC with 3 input XOR gate, or either you will construct two off adder circuit to provide an full adder circuit. So this logical diagram is constructed by using the two off adder circuit. Okay, this off adder circuit. But this is constructed by using the 3 input XOR gate. Afterwards, it is connected with the AND gate. Finally, to provide and carry output, this 3 AND gate was connected with OR gate. So this both the logical diagram will be correct for full adder. What is the advantages of binary full adder over off adder? The major benefit of the full adder over the off adder are listed below. It can perform complete addition when compared with the off adder. So full adder has the capability to do the complete addition. It can also perform the binary subtraction. can also use it to implement various complex arithmetic circuit like parallel adder, multiplexer, and more. It performs binary addition at a relatively high speed. When compared with off adder, it can able to do the operation with high speed.